circular cone inside the sphere. What's the largest one?
Circular cone. I'm not sure what kind of cone there would be. Oh well. All right, let's see. So this is number 7 on the practice final. It references number 52, right?
52, yeah. 52. No, the 52 is
54. Okay.
Yeah.
So the one about the cone inside of a sphere. So you got a sphere. Whoa, that's exaggerated. Oh well. And then you have this cone. So the idea with the cone. For me, that's pretty good. Ooh. Oh yeah. Okay. So now you start to understand why, looking back, even whatever you feel about rotations, it makes you look at a problem like this differently. Because I can draw the triangle and realize if I rotate a triangle, it becomes a cone, right? If I rotate like halfway. Does that make sense? So that's why drawing just the triangle, because what I need here, so say the radius of the sphere, just to keep it consistent, I think on the answer key I call it little r. Yeah. And so I need a radius of the cone, because what's the volume of a cone?
1/3 pi r squared.
Kick ass. Circle repeated this much time, and then cut it in thirds, so you cut that out of the cylinder. So let's make this, I can't remember. Oh wait, that's not the right one. Let me see what I did here. I want to keep my variables the same. Where are you? There you are. Oh yeah, so I call this R here, big ass R, for the cone. So let me call this big ass R in the equation. So we're all talking about the same thing. Okay, so, and what else do I need for the cone? And again, just to really make sure you guys understand, the cone could be here, fatter, or it could be skinnier. So that's just an arbitrary position I've put it at. So I need the height. So we start to piece together the height. So when I draw the height into the cone, how does that relate to anything? Yeah, how big is this here? R. Little r. And then what's this? R.
So
it's no r at all, dude. If it went all the way to the end, it would be little r.
So it's
R. Why would it be this?
R minus x.
Yeah, call it x or whatever. What did I call it?
Y.
Yeah, it makes sense. I call this y because it's up and down. So what is the height?
R plus y.
R plus y. You guys with me so far? I mean, this is the part that people mess up. And this is, if you mess this part up, nothing's going to work. You have to identify what they tell you. How does it relate to what you need? So what did I do? I drew the picture from what they told me. I wrote the formula down for what I need, and then I step back and say, okay, how do I get what I need from what they told me? Right? All right.
Professor, you could also do like y minus, or r minus y, right? Like if you decided that y would be the...
Oh. Well, r minus y would be this little piece.
Right.
Which doesn't really relate to anything.
Well, it would be minus y, so it would be whatever the height is minus y, which is the piece. But is that just too many variables?
But I really just want this height of the cone.
Okay.
Do you know what I'm saying? Yeah. Okay. So I got the height of the cone. I have too many variables here, right? There's too many freaking variables. So if I draw the triangle by itself, that's this cross section here. And so here's R. And here is, this is R here, right? Well, I'm sorry. Get away from there. This is y plus r. What am I trying to say here? The height here is that. Cool. What else did I do? Oh yeah, cool. This one. So here's the nice thing. Right in the center of this This is why it's difficult to draw this by itself. This is the center of the circle. So what's this here? What are those? Little r, right? I like it. So what I need is I need a relationship between y. This is the variable that I just took out of nowhere. So I want to get rid of that. That's not a variable related to anything about the sphere. So I need to replace it. So I need a relationship between y and the r's.
Pythagorean's theorem.
Yeah, so here again, this is beautiful. Little right triangle. Yes. So what's big R squared? Or what can I set up here? Big R squared
Plus y squared.
plus y squared
Plus r squared.
equals little r squared. So big R squared is r squared minus y squared, for example. Right? So can't I put this in place? See why I solve for r squared, so I don't have to bring any square roots into it, right? Because I have an r squared in my formula for what they're asking me. Do you guys follow? I mean, I'm trying to show you the thought process behind what to even try to do. So h is right here, plug that in. R squared is right here, plug that in. And it's all, what am I trying to get rid of? I think that'll be all right. Yeah. Oh, yeah, because we're going to do derivatives, right? Let's see. This is the problem, is an optimization problem.
Even if you do that though, won't you still have two variables? Like,
Volume of the largest circular cone. I like it. Cool.
or which one is it called?
The big one.
No, big R.
Little r is constant.
Work out.
It is.
So which variables here did I make up?
You made a
Little
big
R.
R.
You guys, which variables here did I make up?
Big R.
I made a big R and a little y.
So that means R.
So I have a relationship between big R and little y and little y. There's no big R, little r, y, and big R.
Is there a reason why you made the top radius big R and the bottom
Just
one?
to differentiate, they're not the same.
Okay.
Yeah, so I have to have a different symbol. So, all right, I just temporarily forgot what it was they told us. But I have two variables I totally just made up. It could have been anything. So they're dummy variables. I need to have one variable, because little r, is it a variable?
No, it's a constant.
No, it's a constant. It's a given of the sphere, right? So I just can't have two true variables. Right? So I needed to replace, so the volume now is 1/3 pi r squared times h. So how many variables are in there? One. Good. So when I take a derivative, it's easy. Derivative with respect to y here, right? So it's not an implicit. There's no, you're not taking through, it's not changing. There's nothing about we're filling it up with helium. No, we're not. It's just sitting there. Okay? So just want to take a derivative and then do what to find the maximum?
Solve for the critical.
Set it equal to 0 so I can find the critical inverse. Yeah, cool. So it's all about the setup and identifying what they tell you and how it relates to what you don't know. So I want to show you, if you didn't do this part, and you try to start working with the volume, it'd be 1/3 pi big R squared times little r plus y. Well, there's an unknown, and there's an unknown. That's no good. Too many unknowns. What are you going to take the derivative with respect to now? I don't know, shit, but if I can get one variable, I can take the dv dy. Yeah, their t. Because now this could be my choice. I could say, well, if I want it shorter, then it would be fatter, right? And if I want to make y bigger, then it would be skinnier up there. So y kind of controls my cone now. I could have let big R control the cone, but why didn't I want to do that? Because here, what's it easier to solve for? Considering it's the r squared, because it's there. If I solve for y and get h in there, it's going to have square roots. No, I don't want to go that way. Maybe. All right. Well, that oppressed the hell out of you guys. So wait.
Can we do 9B?
9B?
D.
D. Okay. Oh, all right. You guys know Tuesday, tomorrow, and Wednesday is no class, right?
Yeah.
Fine. Oh, before I get too far from this, please tell me I brought it with me. I didn't email you guys because I knew I was going to see you today, but my schedule for this week. Oh, come on, Jeff. Where'd you put it?
So you said you need to x to the 4th over 5. And D was this. So what you have is this, right? So you have to pull up.
Oh, did I? That's good.
Wait, hold on.
I printed it out for myself and decided to leave it on the printer. So
This.
that's helpful.
4/5.
All right.
So it'd just be 4/5.
I'll pull up the email.
Well, you wouldn't pull out the entire 4/5, right? Because you want 2 left over, so you would just pull out 2. Because you want 2 here, right?
No,
Well, actually, no,
the
you want
derivative
this.
is
You want
4/5.
this. So you would multiply by 2. If you multiply by 2 fifths out here, right? And you would, this would go to 4. Over 5.
All right, so this is 9D.
5 over 2.
What?
Oh, I did it wrong. Oh, I didn't know that was the exponent.
Yeah.
Never mind.
Oh. So this one, what would you do here?
U equal
It's
the
product
4th over 5.
Yeah, u equal x to the 4th over 5. Then du is
4x to the
3rd over 5.
dx.
Which then you just
Now, some of you guys, it's really weird to me. Some of you, I don't really know how to
Yeah, I
create
thought
this.
4 was an
But
exponent.
some of you guys are just putting stuff.
I didn't know 4 was an exponent.
I'm not sure. The 2 can come out of the way. Get the 2, just take whatever's there, get it out of the way, and then multiply it by what you need so that 4/5 shows up. So what do you have to what do you need to multiply here to undo this? 5/4. And then you just see what happens out there. Some of you guys aren't sure how that number gets there. It's nothing vague. It can't be. It's whatever it needs to be out there so that you can put what's supposed to be in there. So if I needed a 3 here, I'd put a 1/3 there. And then whatever's already out there just multiplies by. Right? It's nothing weird, nothing like just put number down and pray. No. So 5/2, and then this integral looks like this is du. This is e to the u, which is awesome. Maybe.
Yeah.
Okay. So this would be 5/2 e to the u,
Yeah.
plus. Don't forget the plus.
Okay. Just checking to make sure. Okay, so 3C. When it says the acceleration when the particle is not moving, does that mean I find when the velocity is equal to 0 and then
Yes.
plug it into the acceleration formula?
Beautiful.
Okay.
You know I like those kind of problems.
Yeah.
On that kind of problem, I give you a position function and I ask you some kind of multi-level. Of course I do, because otherwise it's
give
way
me
too
two
easy.
answers, right?
One answer. I want to know what the acceleration is. When the particle's not moving is just the middle step in the problem.
But isn't there a square root of all? I remember doing that. I seem to remember getting 2 like plus or minus answers.
Yeah, there's 2. Yes, I'm sorry.
Oh,
Because when you find the acceleration, the particle's not moving in 2 places.
yeah.
To find the maximum velocity, do you set the derivative of the position function equal to 0?
What's the derivative of the position function?
Velocity.
And then you're telling me you're making velocity 0 to find the biggest velocity. So I really want you to find the maximum blank.
So like
You
the
set
maximum.
blank prime to 0. Whatever. I don't care if it itself is the 80th derivative of something else. If I want to find its maximum, I take its derivative and set it equal to 0. So here I want to find the max velocity. So I take the derivative of velocity, which is and set it equal to 0.
Oh, so you take the derivative of the velocity function.
Exactly.
Oh.
To find the maximum anything,
Oh.
you take the derivative of that thing and set it equal to 0. To at least get the critical numbers and see what's going on. I like it. So when you take a derivative, you create a function. It's a function in its own right. Right? You want to see these functions march around Washington. We're your functions too. Screw you. Feisty functions.
What's up? Yeah, 8A is L'Hopital's. Well, some of them are L'Hopital's. Only the ones that are indefinite are L'Hopital's. And if they are indefinite, you need to find a way to make it into a ratio. And then take the limit of the top and the bottom.
Yeah. Like number 8A. Number 8A, is that L'Hopital's?
No.
Hell no, it can't be, because the top is 3. So there's no way it could be L'Hopital's.
So it's just
Because it's not
infinity, right?
Yeah, it's 3 over 0, which is approaching infinity. Good. I like it.
Well, then these ones are already in a ratio. It's like B would already be in a ratio, so you just take them.
Yeah, and C is neat.
Yeah. Would you just divide by 1 over the other ones?
Yep.
Okay.
You force it into a ratio. I like it.
There was a question I had that I can't remember what that was. Okay, so
Just the fractions or the
so for 2D, since that's already with the x squared on the
Am I
top, do you
doing the one that I was
just
like
plug x squared in wherever there's a t and then you're done? No.
The inside function is x squared, so when you take a derivative, you have to do the chain rule. So alright. Guys, watch this. So the chain rule is made up of the basic idea of the derivative of whatever the function is times the derivative of the inside. So the basic idea of the derivative of this function, something that looks like this. If I took its derivative, what would it be?
F of x.
Yeah, f of x. Cool, right? So, but if this was x squared, I still, when I take the derivative, I apply the basic idea, which is it's the function evaluated at this. Right? So it's f of x squared times, then the chain rule says, hey, it gets a term. The x squared gets a term times 2x.
Okay. But if you have that in 2 places, because you have t on the outside and a t on the inside of the function.
Oh, sure, whatever this function is. So in that case, the function is t, what was it?
Cosh. T.
Cosh t squared?
Yeah. No, just t.
Cosh. Oh, yeah, that's right. That's squared. That's the function of t. That's the function of t. So what's the answer going to be? So the function of x squared. So plug an x squared in place of t.
And
Of course, wherever t is, because that's the idea of a function.
And then you
Times 2x. And I love it when people take derivatives on the final and they start putting plus c on those. I don't like I'm just going to put plus c in every damn thing. Well, then you'll lose points the other way. So don't do that. Only put plus c when you're supposed to. What am I supposed to? Guess you'll find out.
Oh, do we need to know what inverse trig is?
No.
Okay.
Yeah, I didn't make you remember the inverse trig derivatives. So so I just won't give you an integral with them. But again, you got to be careful because most of the time I'm more restrictive than most teachers with the amount you have to know yourself. I don't know if you guys agree with that statement or not. But some teachers will expect you to know what that is, for example, just on sight. I think so. Personally, I don't have them memorized, to be honest. That's why I don't make you memorize them, because I didn't want to
I
memorize
just know it doesn't have a reason.
In Math 280, you'll learn a way to do this that's not too hard if you don't remember. It's using, not surprisingly, it uses what's called Trig Substitution to do this. Okay. You sure to take that? Sounded halfway between sincere and not. Whoa. That's amazing, Mr. Waller. Alright, so what's up? What's next?
Let's see.
Then again, like number 12, I'm going to give it to you just like that, just the way we're used to. I'm going to give you the answer, basically. You just have to tell me, show me to get there. If you can't get there, then skip it.
I think I did something. Because I was getting something really funky. I'm not sure if I did that question.
Number 12?
Yeah.
Yeah, same here. I wasn't getting the same verified.
Yeah.
Alright.
Can we just do that one?
Sure.
Well, I got the verified.
You got
but,
the A?
Yeah, I got A and B. I mean A and C. I just like when I was graphing it, I got something.
Did I don't think I graphed it.
Because I plugged it into the graph and the calculator double checked, and I got something way different than what the calculator got.
Oh yeah, I guess I just stopped at A and C. That was evil. Why did I do that?
Wait, where?
Number 12. We might as well do number 12.
Yeah.
Alright guys. Number 12.
Where is it on the
Where do trig babies come from? I don't know. I'm not sure what that is up there. Alright, so number 12 says... Alright, so how do you do this guy's derivative?
3x plus 2 squared.
Yeah, so it's what, fundamentally?
The derivative of A times B plus
Product rule.
A times the derivative of B.
Plus...
X plus 2 cubed at 1.
Good. Alright, I like it. And then you just gotta factor this.
Yeah. You just plug 2x plus 2.
Well, you plug in 2, no, you plug x plus 2
Yeah.
squared. Okay.
Yeah, 2.
Well, 2. And then you get 3x minus 12 plus x plus 2. You see that?
Yeah.
3x minus 12. So 3x plus x is 4x. Minus 12 plus 2 is minus 10. So there's your 2x minus 5. So this should be what I have there. What happened? So again, inside here, if you take that out, you'd be left with 3x minus 4 plus x plus 2, right?
3x minus 12 plus x is 4x minus 10.
And then take a 2 out.
Yeah, and you add an equal.
Cool.
Then you do pretty much the same thing for the other one.
Why was
And,
it stressing out of that?
might as well do part C now.
Yeah, 5.
So part C. Is that right?
Yeah.
Oh, wait. It's not alright. You shouldn't be saying sorry. So 4x plus 2 times 2x plus 5. There you go.
Yeah.
Plus, so derivative of this times this plus this times the derivative of this. So what can I take out?
X plus 2.
Yeah,
And
4.
a 2 here. Oh, 4, yeah.
What's left inside? 2x minus 5
Minus, well, plus X plus
plus
2.
x plus 2. 3x minus 3, so I can pull out a 3, makes it a 12.
Yeah. The only weird thing I got was when I grabbed it.
Alright, I'm going to take the message away, so hopefully, just, see the nerds. They haven't bought their lanyards yet to identify, or their pocket protectors, or whatever.
I have a pocket protector.
Protector. I like that.
Protection.
This side of the body's strong. Nerd. Oh, my pocket's over there, so I'll be there. Where am I at? So part B, intervals of increase, decrease. So of course to find that, so part B I'll put right there because it uses this. Where is the derivative of 0? Where's the slope? Horizontal.
0 and 5 and negative 2.
Nope.
For the first one?
Negative 2
Oh,
and
5 over 2.
5 minutes. I like that.
Duh.
So negative 2. What are those? What are those called?
Zeros.
More specific to the situation?
Uh,
Critical numbers. I like it. And it's a really good place for multiplicity. If you don't know multiplicity, a little tear comes out, but that's all right.
So if it's negative 3 plus 2 is
Yeah, if you put a 0 in, I get positive times negative, so it's negative in the middle.
which means it's negative on the
Good.
side of 2.
Yeah.
Good, because at negative 2, it's even multiplicity, so it's going to stay the same. It's going to turn just like a parabola would. And then 5 halves is going to change signs because it's odd multiplicity, so it'll be a plus. Now, if you don't like that, you plug a 0 in, you plug a negative 3 in, you plug a 4 in, get the same signs, who cares?
Wait, you're plugging this into the original, right?
I'm plugging it into the derivative because I want to know where is it increasing would be a positive slope. I've got to use this.
You're plugging in the zero?
so then it would be minimum at 5 over 2.
Yeah, so if I plug a 0 in, what do I want to know about that? I want to know what the slope is at 0. So what am I going to use? I'm going to use the derivative formula, yeah. Okay. If I want to find my maximum point, in fact, what's the only thing this asks?
Do we have to find maximum points for a question like this? Because, I mean, it's 5 over 2, but do we have to find the y value?
Of course, well, I say point, right?
Okay.
Yeah, so when I say point, you better give me 2 parts to it. So what is this now? The 5 halves comma something or other is going to be the what?
It's the minimum.
Minimum, because it goes down to it and comes up from it. That seems almost too easy to believe.
Plug that number into here.
Plug that into there and you get something. Oh yeah, I didn't do it. Shoot. Oh, that's why I didn't do it. Go ahead. Good. So if you plug a 5 halves in. Calculator? Oh, is that it?
Yeah.
All right.
Thanks.
Sure. Poor guy didn't deserve that. Hopefully he didn't hear. Anyway. He's gonna buy more Christmas presents for that. So what are you? Anybody doing that for me? Nobody's doing that for me. My Chris.
I'm trying. I'm trying. 2.
Oh, gross.
Minus.
About negative 137.
Oh, yeah, I got this now.
Okay. All right. Cool. I like it. That seems like a good candidate for a minimum. Although you can't tell if I just say that. You don't know if it's a max or a minimum. All right. And so what about the intervals of increasing?
Increasing from negative infinity to 5.
No.
Decreasing from negative infinity to
5 halves to infinity, decreasing from.
From negative infinity to 5 over 2.
No.
Wait.
At negative 2, is it doing either one? No, it's just resting.
Yeah.
Infinity negative 2, union with negative 2 to 5 halves. Cool. So be very careful about that. You can't include a 0 spot. That's why these have parentheses on these instead of brackets, because at 5 halves, it's not increasing. It's also not decreasing. So I think there was a book, I think it was in pre-calc.
Yeah.
I disagree with them on something. I'm like, those dorks. Because at that point, it's not doing either thing. If I throw the pen up there, right when it gets to the top, it's not going up and it's not going down. So there should be a parenthesis on that bad boy. I'll let go of it, sorry. All right, so that's all I asked for there, right?
Yeah.
And then D says the same thing with concavity. So where has it got zeros? Where are the critical numbers for that?
Negative 2.
And negative 2 and 1. Everything's a multiplicity of 1.
So that means
I'm going to change signs everywhere. I do this, put little zeros. You put whatever the hell you want to.
2 minus 1 is 1. 2 plus 2 is 4.
Yeah, you put a 0 in, you get positive, positive, negative. Negative, positive, positive.
Plus.
So then you can draw if you want to a little cup up, cup down, cup up. So where are the inflection points? Be careful, inflection points, if this was negative, negative, that would not be an inflection point. Right? Just like that would not be a min or something, right? So
Negative 2.
the IPs, IP freely,
Negative 2.
and negative 2,
still
Negative 2, 0.
0. Yeah, that was nice. Or 1,
Negative 81.
Who?
Negative 81.
27.
2 cubed.
Yeah, negative 81. Cool. and then concave up, concave down. Where's the concave up?
Negative infinity, -2.
Or
And
1 to infinity. Concave down will be everything I haven't said yet. Maybe 2 to 1. Cool. All right. So what's nice about the way I've done this is I can take all this away and I've got all my what I need there to graph this. We're doing all this because I think this is the only thing I put on the answer key. I didn't do the rest just because I didn't have to. I don't know. No, we'll do it now. I guess this is what Pasney was thinking. All right, so let's see what we got. What kind of a scale does it look like I need? I need to get down to
Negative 1.
negative 37, negative 81.
So by 20. Or by now. 40.
Sure, fine. So we'll do about 40. 40, 80, 120, 160. Or 80. Let's see, blah, 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 blah. So, trust me on it. Now, some of you guys don't believe that I can tell when a graph is copied directly from the calculator. It is so desperately obvious. So don't do that. Just don't. Honestly, try to put it down based on what the work you've done. If the work you've done is wrong, I want to see the correct interpretation of it on the graph. The graph won't look right, but according to your work, it will, and you'll get more points for that. Because part of what I'm testing you on is can you convert what this means into what it is visually. And you're just copying from a calculator, then you didn't do that. You lose points for not having done that. Okay. So even if your work is wrong, I'm still going to give you some points if you get it translated correctly. Let's see, what kind of scale though on the x-axis? Looks like I just used big 1, 1, 2. I only need to get up to 2.5, right? 3. Alright. Coolness. So let's see, we got negative 2 zeros and inflection point. Let's do minimum first. So 5 halves, negative 1. Oh, that's good, Jeff. Let me do that in a different color. The other black. Negative 137 is about right. There, sure. So this is my min. Negative 2, 0 is an inflection point. And 1, negative 81 is an inflection point. And what's my y-intercept?
0, negative 32.
Is that cool?
Yeah.
Yeah, cool. So 0, negative 32 is about right there. Alright, is that everything? I think that's everything. Did I get
One more x.
another x-intercept?
1, 0.
Negative 2, 0, and 4, 0. Aww. There we go. Okay. And you know the end behavior. And see how pre-cal keeps creeping in? So what's the end behavior for this thing? What's the overall largest degree?
Q-third.
4th degree.
Okay.
Because this is factored. If you multiply it out, you don't multiply it out, dear God. But just realize the largest degree you'll get is x to the 4th, right? Can you see that?
Yeah.
No need to multiply it out, just realize what it would be. What is the 4th power? It's positive 4th power. What's it look like?
It's like a W.
Gold. Right? Alright, sorry. So it should be up back here and then up on the other side. So that's enough to get me started. So it's concave what? To start with. Alright, concave up. It's starting up here, so it's concave up, and then it's going to change right there. So I would kind of so what I do is, so that's concave up so far, right? Well, yes, ma'am.
I have a question.
Oh, this is gonna be
Drawing
hard.
the graph.
Yeah, that's what I had.
When you're drawing the graph, are you using the starting point from your concavity or your
So what I just did, I used end behavior to tell if it's up here or down there. Or you just plug a number in, to be honest, but end behavior is good enough. And then as you draw it, you're going to use the concavity, what it starts with. And the beautiful thing is you just need to get started, because now you just follow what the words say. Like here, I'm not going to go below there. Here, if it's concave up, it's going to become concave down, or vice versa, right? If I label the points, I know what to do when I hit that point. So this is going to be gross. My scale is bad, but I won't. It's got to be concave down now, right?
Yes.
So it's going to concave down up to here. So what I do is I kind of draw backwards. Concave down, concave down, concave down, bam. Just overemphasize it because you need to show me you understand what concave down means, or even just what this means. Right? How are we doing? Okay. That's something else. If I see something really freaky that sometimes people have these little twists that there's no way you can tell from your work. It's only if you look at the graphing calculator you can tell. I don't need that. I don't want that. And now here, what happens?
Goes back to cup up here.
Yeah, so now it goes back to cup up through here, right? So now I can do something. That's the minimum. Bam. So you got your cups in the right direction and so forth. So I use these as the middle point. I don't draw through them because I really want to emphasize my concavity, right? Because some of you guys are not careful and you do things like this. Why would I take points off for that? Because now someone can concave down and there's an inflection point again. So that might feel like me being too picky, but that's the whole point of the problem, is to know when the graph could do changes like that, and then to accurately portray them. So that's why you would lose points there, because that's the point. Okay. Me, old Mr. Look at all the people who scared me. I did, man, this is crazy. I looked it up, though. I still feel bad that so many people drop it. To be honest, a lot of the average, for example, of people that dropped was like a 50-something. There were some people that dropped that were doing really well. They just decided, they realized they didn't need this course. They changed majors or something. So some people dropped for that reason. Most people that dropped were in need of a refresher before they taking this course. Right, so that's what happens. But also, every calc class has lost like 20 or something %. I'm like the second best retention, and I've lost like 23% or something crazy. It's insane. So I thought I must be at the bottom, and I looked everybody up, and I'm like, holy shit, I'm at the top, almost. That's horrible. So I don't know what's going on with our pre-calc. All right, cool. Is that good? Anything about this?
So most of my problem is just drawing a concavity. So you draw backwards like that because I have
Yes.
problems with the first inflection point. I'm like,
Yes. This is easier. If you come at it from the other direction, you really force yourself to do if you try to go through, your brain sometimes does things, but you come from the other side, you'll literally force that concavity. So I don't want your graph to be perfect. I want your graph to show me you understand what this means. Which means it's going to be overemphasized in some places, which is beautiful. The way it should be.
Are there going to be how many problems are there going to be on the test? Like something similar to the practice test, or is the
So how
practice
long
test-
do we have for a normal test? So for any normal test? An hour and 50 minutes. I don't know if you guys...
so
1 hour...
10 minutes actually.
Or is it?
This is 2 hours.
No, an hour and 20 minutes. Isn't it?
Oh, wait.
12:30 to
Yeah.
1:50.
Yeah.
So this final can be... Sorry.
Yeah.
12:30 to 1:50, yeah. So an hour and 20
40
minutes.
minutes actually.
The final's 2 hours.
That's how you know you're.
So it's going to be about
Wait,
3 or 4 questions longer than normal.
So it doesn't stop here unless it says.
That's
Not-
kind of calms the nerves down.
Not with everybody A through B and
Yeah,
A, B, C, D, E, F, G.
Where
3 problems.
Yeah.
Because
Honestly, that's.
So it's going to be a little bit longer than a normal test, which is good because there's a lot of stuff I got to put on there. Oh my God.
yeah, if he says first.
Thanks, Jeff. That made me feel better. Everything this semester.
Are you gonna have one problem from each concept on there, or how does
He
this,
wants the intersection.
like,
I think that'd be kind of
each
different.
problem
Which
has
way
to
it's
work a
gonna go.
lot, or what?
That's what I'm thinking it is. Yeah, so you had to continue the graph until.
So if I'm you, I mean, let's identify the stuff that you tell me. What do you know I'm going to put on there? And I'll tell you. All right. Rotations. I like it. So you know I'm probably going to have a shell and a disc some kind, right?
That's fine.
That's given. Because I have to see if you can tell the difference. I could make a problem where you don't actually do the integral, and I just say, identify which method to use, and then set it up and go do the integral. You know I'm going to have to do one where you have to do the integral, but those can sometimes take a long time. So I have to, so for example, as a teacher, I have to know that you can tell when to use which. I have to see if you're able to set it up based on which method you know you should use. But that doesn't mean and then I can test your integration methods at some other problem, right? So either I'm going to make two problems where I have to integrate both, but there's going to be less integration problems, and you're pretty much sure that that's not going to happen. Or I'm going to do a problem where you have to identify, but you don't have to integrate. And then I can make it whatever the hell. I can make it not even integrate. You know? So be really careful. Pay attention if I say no need to integrate. Don't waste time. That probably means you can't do it. What else do you know is going to be on there for sure?
Related rates. Concavity, inflection.
Related rates.
Optimization.
Implicit might not be, but we'll see. It could be.
Really?
What do you mean? You want one?
Yeah, like take off an optimization.
Oh, yeah.
I like this. This is like
Let's
negotiation.
do related rates.
No. If you take off an optimization, I can give you. It's like, what are you talking about? I'm sorry. That was. There are certain groups that like to haggle. I'm not a person that likes to haggle. I'm like, just tell me how much the freaking thing costs. Let's see what else. The position, acceleration, that kind of stuff.
Yeah.
More than likely. L'Hopital stuff, right?
So L'Hopital is
Definition of derivatives.
You know it is. You know it's going to be in there.
LH.
Yeah, definition of derivatives should be fine.
U sub, it's definitely going to be on there. That's huge. Probably a U sub that involves solving for X, right? That little flexibility. Everybody had one like that on the quiz last time, I think. You know I'm going to have trig that you have to give me the exact answer for. You know that's going to happen, so just review your trig. That's all. Just review trig. A few minutes, review trig.
You won't give us cosine sine.
What's that? I don't know if any are not going to be trick questions. I think they're all going to be. They're all going to be trick questions.
Well, like for some of your quizzes or tests, you have like, what's the derivative of pi?
All right, so I don't consider that a trick question. And the reason it is, for example, now I'm giving something away here, and I don't care. I could probably give you, what kind of integral? Can somebody set up a definite integral that is you can't do? And I don't mean because the function you can't integrate it, but because the integral is not defined. What has to happen?
You have to have a zero on the bottom.
No. Come on
You have to
now.
have a zero on the bottom.
Exactly. So the easiest one to do would be integral 1 over x from
0
to 5 or something. Or just anything including 0, of course, right? So technically the idea of integral can't even work. And remarkably enough, what I'm going to say next. In a future class, you'll learn how to kind of work with that to see what kind of infinity it is, if it is going to be infinity. Kind of with me? So you do infinite integration in, I'm pretty sure it's 280. Yeah, I think it's 280.
So when we get an integral that doesn't work, do we just say infinity or like?
Or it doesn't work.
Yeah, you don't even know how to identify right now which one it is. Yeah.
I know.
It's a mean question.
It's a question with a benchmark.
I know what you're thinking. I think I know what you're thinking. That they fill each other in, right?
So like -1 to 1, it cancels out, and then the rest.
God, I feel like I'm missing something.
I feel like it's a concept
Nope. Too bad.
that I'm like, no.
Epsilon?
The complete story requires some stuff that you learn in 280. But for example, if I go from -a to a of an odd function, right, then it should come out to be 0. You guys remember that?
Yeah.
So give me an odd function.
So,
X cubed.
All right.
so then you could do that with the -1 to 1, and then that cancels out, and then you do the.
No. So two things here. I'm thinking about a different. If I had from -infinity to infinity of x cubed, I can't say directly what this is. I can't. because infinity minus infinity is an indeterminate form, right? So these a's are assumed to be finite in this definition, in this idea. Secondly, if I had negative 1 to 1 of 1 over x dx, the idea of integral requires a continuous function, right? And you actually talk, in 280, you're able to talk about, believe it or not, the idea of infinite sequences in series. Series are adding up an infinite line of numbers or expressions. You guys kind of with me? So sequences are like 1, 2, 3, 4, 5, or 1, 1, 2, 3, 5, 8. You know, the series would be adding up all those terms. And that's integral is an infinite sum. So those two ideas seem to go together. So once you learn more about sequences and series, you're able to come back and talk about this more directly. Infinite series are kind of weird. Some of them you can make the answer anything you want it to be. And if you look at YouTube, there's a ton of videos about people trying and failing to explain why that is.
That's great.
That's great. YouTube is great. Waste of time.
Except for Patrick doing too.
News bloopers, yeah. Look at that. I like turn off for a while. Let's turn on YouTube. Alright, that's beyond this class.
Okay, thank God. Thank God.
Like I said, this is I like that I can see exactly what you're thinking, but you got to talk more. Right now, the official definition requires a continuous function. So we already talked about like piecewise functions. You just break the integral up into its parts, and then each part is continuous. So there are definitely ways around it. We just don't have a formula. We haven't formalized a way around this. Yes.
As far as like trig identities, like, you know, how we have like, for example, like from negative a to a of like a constant, would it still be like 0? Like stuff like that. We would need to know that for final.
Well, a constant.
Nah, if you were to integrate a constant.
No.
Because I remember doing trig identity properties.
Like arctangent and stuff?
No, it was like the rules where you can like add to interval or like stuff like that. Yeah.
Oh, you're talking about the symmetry or something? The symmetry?
Is it properties of it?
Because like if you integrate cosine from negative pi to pi or something, or else make it negative pi over 3 to pi over 3.
No, more like
Well, real quick, just to finish this idea out,
okay.
how could you rewrite this? Cosine is how related to the y-axis? I love that question.
What do you say?
How is cosine related, or what symmetry does it have?
It's related to the x-axis.
Do you mean?
It's
It's evenly symmetric, so it's symmetric to the y-axis.
Yeah.
So, therefore, the integral on one side would be equal to the integral on the other side. So I can rewrite this as twice the integral of 0. This is what I thought you meant, but right? That's the place where people try to do this too often. Rotation stuff, you got to be real careful. Basically, if you're not sure, just never do it with rotation because it's not. You can't just look at the 2D idea and say, "Look at that symmetry." It depends on how you're rotating it. If there's a piece further away, screw it. Just don't do it with rotation. All right? Don't. But I don't know then. What's your
there is like different rules of, is it properties of integrals? I'm trying to think. Like if you have, let's say, there's ways where you can change, like one of them is like if it's from A to B, let's say, and you want to make it from B to A, then it would just be negative.
Sure.
What are the other ones? Like that's the only one I know.
The other ones are kind of silly. Watch. You'll see what I mean. Help me out, Angela. How do you integrate this? X plus 3. How do you integrate that? I'm putting you on the spot, I know, but don't.
X squared over 2.
Yeah. So you automatically did, without thinking, another derivative property, which is the integral of f plus g is the integral of f plus the integral of g.
Yeah.
That's a silly property. But what it's really saying is integral is linear in that respect because it looks like it distributes. It doesn't actually distribute, but it just looks like it. Derivative has the same property, right?
Yeah.
Derivative of a string of things is derivative of each piece, thank God. Yeah. But it doesn't, multiplication you got to be careful about, right? What really kills me is when there's an integral of like x over x plus 1, and somebody tells me the answer is x squared over 2 over x squared over 2 plus x. Yay! Right? It's sort of like, inverse L'Hopital's or something. It's not on a limit, so too bad. And it's funny that nobody's thought about, does L'Hopital's work in reverse? No. Too bad. Too bad. Because it's hard to recapture what any constants were to make it actually work. You could do something with it, but it's nothing we worry about. Alright. Anything else before I keep going off on weird tangents? Like what's what you do, Jeff?
Can we do 9C? Wait, did we already do that one? No. Wait, maybe it wasn't 9C. Hold on. It was 2C.
2C?
Yeah.
So what kind of rules do you need to do the derivative of that one?
Just derivatives. I don't know. Product rule.
Product rule. I like it.
Whatever.
That gets you started.
Power rule.
So this guy's derivative.
So it's whatever. So it's 6t e 2t minus 5t cubed plus. Then that's going to be 3t squared and then e to the 2t minus 5t cubed. And then
What's
you have
that?
2
What's
minus
missing?
15.
Yep. 2 minus 15t. And I just cleaned that up. Right. Clean it up.
We take out the 3t and then have e. Maybe I just wrote down an equivalent form.
I don't know. Let's see. What did I write down?
3t e 2t minus 5t cubed.
2c.
And then you factor.
Yeah. You can take a 3, you can take a t, and you can take the e. Right. 3t.
Ah.
And then there'll be 2 plus t times this.
Gotcha.
Today's calculus is brought to you by.
We won't have like Riemann sums.
Yeah, I like that. Really confuse the hell out of kids. I like it.
We won't have like.
Not the letter E, Mom, the number E. What's that? What's going on? Oscar the Grouse is like, it's a letter or a number, leave it alone.
Are we gonna have
Yes.
Riemann sums? Like
What?
there's limits broken up.
Riemann sums? Or you have x minus x, or the function of x divided by
Yeah, then you have that.
No.
Okay.
I'll tell you that right now. Did you miss that? Let's do that. I'll let them decide if they want to talk. Yes, ma'am. I'm not going to make you do Riemann sums.
Oh. We should review.
That's an idea that's going to come back in 280.
Those are the easy ones.
You with me? Because in 280 you learn. Remember I talked to you a little bit. All I said was this. All I said was you could do a trapezoid. There's a trapezoidal rule. So engineers, if you look up engineering stuff, calculus required for engineering, they use a trapezoidal rule and modify trapezoidal rule for stuff. It's where you can take observations. You don't need a function. You just need several observations.